In this question, we are asked about alkanes, and we know alkanes are homologous series of saturated hydrocarbons, which means the carbon atoms filled with maximum number of hydrogen atoms. So here we are asked about C4H10, which is a butane. We are asked to draw the structure of two different alkanes with the molecular formula of butane. So an alkane can be branched and unbranched. First, let's draw unbranched alkanes. First, we draw all the carbon atoms in a chain, and then we fill the rest of the hands of carbon with hydrogen. We can pass through this in a straight line. However, in a branched butane, this is a branched butane. Here we have 3 carbons in the same line. However, if we need the butane, we need another carbon which we put in the center here. So here we cannot pass through the whole compound in a straight line. We have to go here, and then this is a leftover. If we go straight, this is a leftover. So this is branched. We cannot pass through the whole compound in a straight line. Next, we have the general formula of alkanes, which is CnH2n plus 2. We have 12 carbon atoms. The molecular formula will be C12H26. In the next question, we are asked about separation of alkanes from petroleum. This is made possible through fractional distillation, where in a blast furnace the petroleum is heated, and when it's heated it gets vaporized and it passes through a tube to the tall fractionating column. And in the tall fractionating column, the lighter weighted alkanes diffuse to the top of the fractionating column, and the heavier alkanes float at the bottom of the fractionating column. And through this tube extended from the top, middle and bottom, we can get each weighted alkanes. Here we can get light weighted alkanes, here we can get heavy weighted alkanes, and then it's distillated to get our choice of alkanes. So how can we write this? First point is the petroleum is heated, pass through a fractionating column. In the fractionating column, the alkanes are derived on the basis of their melting point or mass. And the extra points you can add is the petroleum is heated in a blast furnace, lower mass alkanes have lower boiling point, so they are collected from the top of the fractionating column. So butane here, it reacts with chlorine to give several products. So the conditions needed for the substitution reaction. So butane C4H10, for it to undergo substitution, it needs to undergo a free radical reaction. So here we need UV for this to form the free radical of chlorine. So one of these products contains 37.8% carbon by mass, this percent of hydrogen by mass, this percentage of chlorine by mass. So to find out the empirical formula of the product, we have to first find the percentage by mass ratio. So these are the percentages and these are the mass. So the percentage by mass of carbon is 3.15, hydrogen is 6.3% and has a mass of 1, so it's 6.3. And chlorine has a percentage of 55.9 and a mass of 1.57. Now this is the mole ratio, and we have to divide all these with the lowest mole ratio, which is 1.57. So 3.15 by 1.57, 6.3 by 1.57, and 1.57 by 1.57. So this is 1. This is 3.15 by 1.57, 2.0063, and this is 4.0127. Now all these can be rounded to 2 and this can be rounded up to 4. However, if there was 2.4, this couldn't be rounded up to 2. We had to multiply it with other numbers till we get a whole number, or a number which is closer to 2.0 or 2.1 decimal. Okay, so here the empirical formula will be C2H4Cl. We know that the empirical formula is C2H4Cl. However, we know that butane is reacting with chlorine, and this will undergo substitution reaction. So carbon atoms won't increase from 4, nor will it decrease from 4. So we will have 4 number of carbon atoms. So to get the molecular formula, we just have to multiply it by 2, so that we get 4 number of carbon. And as we have multiplied this by 2, we have to multiply all the other things by 2. So we get C4H8Cl2. So this is a disubstituted butane, which is our answer.